Hello students. Today we're going to learn how to solve systems of equations using the substitution method. Our purpose: by the end of this lesson, you should be able to solve a system of equations using the substitution method. So how do we solve systems of equations using the substitution method? We're going to learn by the following example. Find the solution for the following two equations: 3x plus 2y equals 16 and 2x plus y equals 9. So step 1, we're going to solve one equation for a variable, in this case y, because if we look at our equations, this equation 2x plus y equals 9 has no coefficient in front of y. This makes it the easiest to solve for y. So let's solve the equation for y. We get the following: 2x plus y equals 9. Since we're solving for y, we need to subtract 2x from both sides, which gives us y equals 9 minus 2x. Now step 2. We're going to use substitution in the next equation, or in this equation 3x plus 2y equals 16. So now we need to substitute y equals 9 minus 2x into the equation 3x plus 2y equals 16. And that's going to give us the following. Substituting y, so what we do is we substitute y here, gives us the following. 3x plus 2 times 9 minus 2x equals 16. And now we need to solve for x. And that gives us the following. 3x, so what we did is we substituted y here, and we used the distributive property to get to here. So we have 3x plus 18 minus 4x, and now we need to combine like terms. So we combine 3x and negative 4x, which gives us negative x. And now since we're solving for x, we need to subtract 18 from both sides. And now we have negative x equals negative 2. And we need to solve for x, not negative x. So we divide by negative 1 on both sides, giving us our solution, x equals 2. Now what we need to do is substitute x in the original equation, or in this equation right here, 2x plus y equals 9, and we need to solve for y. And that gives us the following. 2x plus y equals 9 is our original equation. We substitute x equals 2 into x right here, giving us 2 times 2 plus y equals 9. So we get 4 plus y equals 9. We have to subtract 4 from both sides, giving us our solution, y equals 5. Now we have our solution is x equals 2 and y equals 5. And let's check to see if our solution is correct by plugging x equals 2 and y equals 5 into both equations. Doing that, we get the following. Since we have x equals 2, y equals 5, we get 6 plus 10 equals 16. 16 equals 16. Perfect. Doing the same thing, x equals 2, y equals 5, we get 9 equals 9, and we're good. So, we have that our solution is x equals 2 and y equals 5. And writing our solution as this ordered pair, we get 2, 5. Now, we're going to solve systems of equations in a real-world scenario. So we have that I Middle is selling tickets for a school play. On the first day, they sold 4 children tickets and 1 adult ticket for a total of $18. The second day, they sold 3 children's tickets and 3 adult tickets for a total of $27. We need to find the cost of 1 child's ticket and 1 adult ticket. So the first step is going to be identify the variables. What are we trying to solve for? So since we need to find the cost of 1 child's ticket and 1 adult ticket, we do the following. We let x equal the cost of 1 child's ticket and y equal the cost of 1 adult ticket. Now we need to create a system of equations, and we do this by the following. Because on the first day we sold 4 children's tickets, we have 4 times X, because X is the cost of one child's ticket. Also, we have 1 adult ticket on the first day, so we just have 1 times Y, or Y. And we had a total of $18. So this is why we have $18. And we do the same setup for day 2. 3 children's tickets is 3X, 3 adult tickets is 3Y, and our total is $27, or 27. Now we need to solve one equation for X and Y. And, in this case, day 1 is going to be the easiest because there is no coefficient besides 1 in front of Y. So, solving for Y, we have to subtract 4x from both sides, and that gives us y equals 18 minus 4x. And we repeat the same process as we did in the previous example. So step 4 is going to be to use substitution in the next equation, which would be 3x plus 3y equals 27. So pause your screen and see if you can do this on your own. Okay? We get the following solution. Substituting y in this equation, y in this equation gives us this. 3x plus 3 times the quantity of 18 minus 4x equals 27. Now, we need to solve for x, which gives us the following. 3x plus the quantity of 18 minus 4x. We use the distributive property. Remember, distributive property. And that gives us 3x plus 54 minus 12x equals 27. Combining like terms, do the x's first. 3x minus 12x is negative 9x. Now we have to subtract 54 to both sides. That gives us negative 9x equals 27. Dividing by negative 9, we get x is equal to 3. Now, since we have the value for x, we need to substitute x in the original equation and solve for y. That gives us, substituting x equals 3, we get y is equal to 6. Now we need to check our solution in both equations. Remember, recall that x is equal to 3, y is equal to 6. We get 18 is equal to 18, so we're good. X is equal to 3, y is equal to 6, 27 is equal to 27, so our solution is good. Therefore, we have that one child's ticket cost $3 and one adult ticket costs $6. And writing our solution as an ordered pair, we get 3, 6. Now, you try the following on your own. Find the solution for the following systems of equations. 2x plus 5y equals 16, and 7x plus y equals 13. And then, the solution for 3x plus y equals 14, and 2x plus y equals 12. Thank you very much.